identity times xt plus 1 is xt plus 1 minus xt, right? Clear? I can replace it by this. Okay, so this will be equal to what? F of xt plus 1 plus xt plus 1 minus xt transpose gradient of f of xt plus lambda by 2 times xt plus 1 minus xt whole transpose times xt plus 1 minus xt is what? Norm of xt plus 1 minus xt. This will be, what is that? Lambda by 2, right? Okay. Now things are nice. What is xt plus 1? So I'm using gradient descent, right? What is xt plus 1? It's xt minus eta times the gradient. So what is xt plus 1 minus xt? It's minus eta times the gradient, right? You agree? So I'll write GD. It follows from gradient descent, right? Plus, okay, this will be minus eta times the gradient of f of xt. Gradient of f of xt transpose times gradient of f of xt is norm of this squared, right? Plus lambda by 2. What will happen to xt plus 1 minus xt? It's minus eta times the gradient. So eta will come out. So we'll have eta squared. Again, this will be, right? So now everything will follow through, right? So you have xt plus 1 minus, of course, eta will come out. 1 minus lambda eta by 2 times the gradient of f of xt squared, right? Is that fine? Okay. So now I can write this in a slightly different fashion. So I can take, so what we have here, it's greater than or equal to, right? I can reshuffle, and so, okay, so what next is, maybe we'll look at it in the next class. Okay. So now essentially it says, so we have f of xt plus 1 here is greater than or equal to this, right? So the difference between these, did I make a mistake? Wow, nobody corrected me. So f of xt, right? It should be xt. xt. So the difference is lower bounded by some constant times the gradient norm squared, right? What is the size of your gradient? How steep the function is at that point, right? Obviously, right? If you have a point and it's very steep at that point, I jump a lot, right? Otherwise, I jump a little, right? So that's how I will go down, right? So we will use this to prove that eventually we will go to a place where it's very close to the optima after so many rounds. How many rounds is something we will characterize. Okay. With this, I'll stop here. Go through this math. We will see various versions of it and various, we look at it from different viewpoints. Okay. With this, I'll stop. Thanks.